Welcome again to another issue of the Southwest Climate Podcast. Dr. Mike Crimmins, how you doing?
Zachary, how's it going?
I'm doing well. It's nice to see you. Holiday season coming up.
I can't wait.
Got any New Year's resolutions?
More rain gauges.
More rain gauges.
In my backyard, yeah.
In your backyard or
for
just
Christmas.
across
just
the West?
Everywhere.
You're like the classic climate scientist. More data.
Johnny Appleseed. I'm going to go walking across western U.S. planting rain gauges everywhere.
So that's your New Year's resolution, install more?
Yes, it is.
Wow.
Somebody else has got to read them, though.
You are the quintessential scientist. Well, thank God we got some rain.
We did. How
In
did you do?
Southern Arizona.
Yep, rained in my house.
The rest of the West, northern Arizona, and much of the other parts of the West have not fared as
Man, oh man, I know.
That rain event was the first precipitation really of significance in 3 months-ish.
For Tucson, we've had a couple of spits of rain in December, but it was our most significant event of the month for sure.
So we're feeling good.
I'm personally feeling good, but I think as we talk to folks across the rest of the Southwest, that's a pretty localized phenomenon. I don't think overall there's a lot of happiness about what climate's been throwing our way the last couple of months.
Okay, well, I bring that up at the onset because the last podcast we did, that was a struggle. I mean, there wasn't much to talk about. So we have a little bit here to report on that some of the West got some rain, not a lot. Some of the bigger picture issues, the sort of dry and hot conditions remain sort of persistent. We have what is turning out to be a strengthening La Niña. Mm-hmm. We might be seeing some of that already in the atmosphere. We'll talk a little bit about that. And of course, the story, again, unfortunately, for California is these raging wildfires.
Absolutely. Not a lot of Christmas cheer in this podcast. I'm looking for some signs of hope out there, but they're just not getting dealt our way. Yeah,
so we'll foreshadow your are you gonna have a pessimistic rainfall winter prediction?
Probably. Okay. Are we going to numbers? We're throwing numbers on the table for that. Okay.
Because you're one up on me from winning the monsoon bet.
Did I win the monsoon? Did I say it was going to be awful? Because it sure turned out to be.
All I remember is you won. I think I went whole hog in on the monsoon, and I don't think it actually.
Oh, that's right. Yeah. I think you were going.
I was going 10 inches.
Yeah. What were you thinking?
Well, I mean, it was the halcyon days of the end of July.
Oh, yeah. It was.
And then we went apocalyptic.
That's good. Nice use of the word halcyon, too. That's nice.
That? I looked that up before this.
That's great.
I have to appear to be smart. I have to rise up to your quippiness.
All right. We have Ben edit in some cool words for me, too, then.
Why don't you walk us through what's been significant in the last 30 days? So what we mentioned was really the recent event that happened last couple of days here in southern Arizona. Why don't you walk us through that, since we're sort of dying
it's tough.
What the heck happened?
So it was mid-November, and we were kind of still reeling from the October that had set records, at least for southern Arizona, with the temperatures and pretty much blanking on precipitation. And then the first 2 weeks of November were not that much to talk about. And I think we were looking forward, and I think I even went out on a limb and saying, you know what, by Thanksgiving, stuff always shifts around and we'll be good to go. Well, that didn't quite happen. The warm, unusually warm, record warm, dry conditions really held through the end of November across most of Arizona and New Mexico. And then we haven't broken out of that pattern. Right now, across the Southwest, the southern part of Arizona and the southern part of New Mexico have had more precip than the northern parts, which is that's not normal. Not normal for the fall transition period. Typically you'd start to see the storms building in from the Pacific Northwest and sort of inching their way down the coast towards the Southwest. And the northern parts of Arizona and New Mexico would usually lead us in precipitation accumulation by this time of year. But the few events that we've had come in have been from the south and have been these little low pressure closed lows that have wandered across. Even, Mexico has had more precip than the Southwest and much of the interior West. Most of Mexico has had above average precip over the last 30 days, including some epic snowfall across Chihuahua.
So these ducked in south of California because California's remained dry.
Yeah, so subtropical jet is south of us and has been taking that subtropical moisture off the Pacific and stringing it across Mexico and into Texas and then parts of the deep southeast.
That being said, we should say that this event, although it was not insignificant, the totals here in Tucson have been around a half an inch. That's a pretty good.
It's not bad, right? So I don't know what the normal precip for Tucson for December. It's probably 1.5 inches total. And so, yeah, we're maybe not quite half of that. So right. It's not great. My bar is so low right now.
Well, I mean, and then if you sort of string it out for the last 3 months, we've had that event and maybe one other in the beginning of November that produced a couple tenths of an inch. So over that time here in Tucson, the last 3 months, we on average receive 2.6 inches of rain or 2.5 inches of rain, and have received just 25% of that. So.
Yeah, and okay, so for Tucson, October is a toss-up month, right? In the historical records, it's kind of feast or famine, and most often it's famine. We don't typically get a lot of precip. November, you should turn a corner, and we should start to see something come in, and we didn't for the most part. And then December's been pretty meager. And we are doing better than most other places in the Southwest, right? Flagstaff has had no precip in December, and we've had close to half an inch with some varying amounts across the southern part of the state. That's not normal.
Yeah,
that's weird.
If you look at the 2.6 inches that we normally get over the last 3 months, you'd think, okay, maybe that's 5 or 6 or 7 different events. We've had one for the most part, and then that one, and I don't recall the one in early November, around November 6th, that produced 0.2 of an inch. I don't think that was much to speak about.
No, I don't. It really wasn't.
Thinking about the sort of regional atmospheric pattern, has there been a high pressure system that's set up sort of basically over California? I mean, are we going back to, the epic years of the past few years when California received all that sort of dry conditions and that epic drought unfolded? Are we sort of in that sort of pattern?
I think it's still hard to say. Yeah. I think that we're still in the early parts of the core of the winter months where especially the Southwest in January and February, March, at least historically, have seen the bulk of their precip. If you look at the last 5 years, interestingly enough, that December has been one of the months where we've picked up a lot of our winter precip just in the recent past. And so that's a little weird jog in the climatology. But seeing October, November, December here, and what we've been sort of dealing with is a really busy, active jet stream with a lot of kind of unusual wiggles in it for the Pacific Ocean and the North Pacific, and then how that plays out for the Western U.S., including us. And so I think really the jet has started to strengthen across the Western Pacific, and then what happens in the Western Pacific translates into the wave patterns you see downstream in the Eastern Pacific and then into the Western U.S. And so what we've seen over the last 30 days is a really strong, very, very high amplitude ridge that's extended up into Canada. And then you've had this diving trough across Canada and into the Eastern U.S. So the Eastern U.S. has had a couple of episodes of cold air outbreaks there, but it hasn't been consistent. We haven't been sort of locked into it. And we've been really, really far from the action. And what we've seen down this far south is a couple of break off, closed lows, even cut off lows that have kind of wandered around near us and have gotten absorbed into that jet stream flow and moved across us. And most recently over the last week when we had our big precip event here, it was a low that really originated way up in the Gulf of Alaska and brought its atmospheric moisture with it all the way down the coast of California and then cut inland, and also dragged up a little bit of subtropical moisture to the south where that subtropical jet had been sort of carving across Mexico. And then that was that convergence of it. And it also was, the jet stream was so amplified that the low pressure system took a couple days to move across the Southwest. And so just that duration of the event gave us round after round of precip, which caused the precip totals to go up. If it were a much quicker jet stream and that wave would have kicked out further, this storm would have been in and out of here in one band of precip, and we might have gotten a couple hundredths of an inch, and it would have been on its way up to the Midwest. This is one of those events that you couldn't pick up in a seasonal forecast and maybe end up being 10 to 20% of our seasonal total that we wouldn't have seen coming. So we got super lucky that we got anything out of this thing.
Well, that's interesting because that pattern that you just described might have been lucky for us in southern Arizona for the precipitation, but it was also sort of what set up classic conditions for these Santa Ana winds.
Yeah, it's all kind of connected together. Absolutely.
the story right now going on is, the Thomas Fire obviously has pummeled and destroyed, I think, if I'm remembering correctly, 1,000 structures.
It's just insane.
There's estimates that billions of dollars. I mean, this is on top of what happened in the wine country in October. And so the difference here is, of course, the mechanism that is, I mean, it was wind driven in October as well, or partially wind driven, but not Santa Ana. And so the Santa Ana winds, maybe let's take a little minute to explain sort of how those things set up and why this is the season.
It's that bigger, longer arc of the story that, you're kind of alluding to is that you've got these urban centers built in these really fire-prone landscapes, and this is the discussion now about attribution. Is what's the main causal factor in why these fires are so bad? And it's a convergence of a bunch of stuff. And I think one of the things that we're kind of now seeing is that the epic winter, which was last winter, right? If I can't even keep them straight anymore, but
no, that was the winter that produced all those atmospheric rivers that really made California. I think that was one of the wettest years, if not the wettest year on record.
That's right. So you have all of that, and again, it's a Mediterranean climate, so it's going to get all of its precip in the winter, and then it turns into just a bumper crop of fine fuels and vegetation growing in the spring. And then it gets dry in the summer, and then it was exceptionally warm across all of the Western California all the way up through this fall. And so the record warmth that we had in the Southwest extended all the way up into the interior West.
And that can dry out those fine fuels quicker.
So, absolutely.
And even not even just the fine fuels, just everything. The larger fuels.
Yeah. And,
which take
and then there's
hundreds of hours to dry out.
Right. There's mortality in trees over the longer term drought up at the high, which is not necessarily what we're talking about for these events. But then you get into Santa Ana season, which is the fall, and as you have this wavy jet stream and transition pattern, and you start to bring in cold air masses up through the Pacific Northwest, and you have the ability to pull in that interior cold, dry air from Canada and move it down south. As it pools in the Great Basin, it's heavy, cold air, and it is working its way out towards low pressure that is in that jet stream pattern out in the Pacific Ocean. And it flows like water out to the sea. And once it hits those passes, it accelerates.
Right. So it's cold, it's dry to begin with.
Mm-hmm. And at a higher elevation. So it's perched up high. So, hydrostatically, it's like having, you could do it in a sandbox, right? And if you made a little watershed and you threw some water at the top of it and it flowed downhill, you'd see where it would speed up in these little channels between mounds of dirt.
So it's also flowing downhill. It's going from the Great Basin down westward.
Absolutely.
So, but in addition, so you've got this high pressure system, and you've got a pressure gradient from from east to west.
Yep.
And so the winds and the airflow is going from east to west, and it's being funneled through the Sierra Nevadas in these mountain passes. And as you push that air into a tighter constriction, it's kind of like putting your thumb over a hose,
right.
And it just
accelerates. Yeah.
And so as it's also descending, it dries.
And it compresses.
It compresses, right?
Yep.
And
so
the humidity actually descends.
Absolutely.
As well. And so you get this sort of the cliche perfect storm. You get drier air, hotter air, and faster moving air, and you can have winds 60, 70 miles per hour that if there is a fire in the area, then all heck breaks loose.
When you think about fire weather, what are you worried about? You're worried about high temperatures, you're worried about low relative humidities, and you're worried about high winds. And so it's interesting that the Santa Ana winds, by their very nature, create all of those conditions concurrently, and the funneling of the winds seems to be a couple of the causes for the actual fire starts themselves, which was down power lines. And so there's this kind of big discussion, out there about, well, how do you mitigate? How do you use the forecasts for these events? Was very good. We have high resolution numerical weather models now that can pinpoint hours to maybe a day or two ahead of where you'd see these accelerations and these winds through these passes. And so there's this discussion and that's where a couple of these fires had started because they blew down power lines, and then those power lines at higher elevations then cause a fire start that's just carried downwind and blew through some of these communities is one of the proactive measures to actually use forecasts to shut down parts of the grid. And you can imagine like that's a really interesting policy discussion to have, is would people put up with having a blackout to prevent a wildfire start during a Santa Ana wind?
Some things to think about for sure.
It's interesting, yeah.
So just some numbers here. I'm looking at some statistics from the Thomas fire, which is the one that's raging still. I think it's only 50% contained in Ventura and Santa Barbara. 1,009 structures destroyed, 2 people have died, right, and about 95,000 people evacuated. According to AccuWeather, they predict that this 2017 California fire season, which includes obviously the Thomas fire, but also the fires that did a lot of destruction in October, over $180 billion. 2017 is going to go down in the record books as California's most destructive season on record. Yeah, so I wanted to go back to something you said before, because as I was doing research for this, came across, actually Ben sent me the paper from 2004 by Anthony Westerling, Dan Cahan, and Timothy Brown, and others, where they were talking about climate Santa Ana winds.
Right.
And I wanted to read just the first couple paragraphs, because I think it's 2004, it's not that long ago, and it's pretty relevant today.
Yeah, absolutely. Yeah,
exactly what you said. And so they write in the abstract, wildfires periodically burn large areas of chaparral and adjacent woodlands in autumn and winter in Southern California. These fires often occur in conjunction with Santa Ana weather events, which combine high winds and low humidity and tend to follow a wet winter rainy season, which is what we had last year. Mm-hmm. And they did some empirics and demonstrated that. Furthermore, over a century of watershed management and fire suppression have promoted fuel accumulations, helping to shape one of the most fire-prone environments in the world. And, they go on to say that, combined with the complex topography and large human population, Southern California ecology and climate pose a considerable physical and societal challenge to fire management. So, obviously we know that fire in the West is a great challenge, and it's a physical exposure story. The temperatures play a role, and the winds play a role, but it's also it's socially driven as well.
The Santa Ana winds they're really a unique phenomenon because of the rates of spread that you have really big epic fires at higher elevations with heavier fuels in forests, and some of them can be really, really rapid spreaders, but these are really amazing in the way that they can spread through these very narrow and populated. They tend to be really beautiful, picturesque, scenic areas that have enormous rates of spread. And you just don't see that sort of combination in other parts of the West in quite the same way. And I think the fact that it takes that unique convergence of situations is why you don't see it every year, right, and why you can end up having 20 years go by before you see that event again, and everybody goes, oh my gosh, this is a really dangerous kind of spot to be in.
Well, also, in that passage I read, there's sort of a link to the immediate previous year and the wet conditions,
yep,
but there's also indication this year that area and all of California is still reeling from the 4-year drought.
There's still absolute drought signals in the heavier fuels.
So according to the U.S. Forest Service personnel, they say it's a record 129 million dead trees in California right now. Right. And it's apparent from our survey flights this year that California trees have not yet recovered from the drought and remain vulnerable to beetle attacks and increased wildland fire.
Yeah, and so I think a lot of those, when you get out to sort of the Forest Service lands, is that you'll end up shifting back as you get out of winter, and we'll see how this winter plays out. If the La Niña impact is as though we expect it to be, you could see parts of Southern California, or maybe all of California, depending on the jet stream plays out, to having the fire season continue and shift towards being the more inland, higher elevation Sierra-driven fire season, which I think is also a big concern for us in the Southwest now too, is that we're now seeing that drought. We're seeing fine fuels that have built up over previous summer, good July. Now we're in a really epic fall drought season here. If the winter doesn't play out, now I'm really concerned about a very big and busy fire season in the spring. And some folks I work with at the Forest Service have already, everybody's getting itchy about how this shapes up for the rest of the Southwest going into next spring.
Additionally, California, I believe, so far has experienced its driest start to the winter season on record. Is that
I don't know.
Yeah. I don't know where. I think I saw that on Twitter.
Did you see that on Twitter? Okay, it must be true then.
Well,
yeah.
I don't know.
Yeah. So again, it's early in the season. Yeah. I think I said that last month. It's getting later in the season. Yeah. We should definitely. Okay, maybe it's not early anymore. Maybe I'm trying to talk myself out of this. It's winter, right?
Well, I think it's the character of the rain that matters. In like 3 months now, it's entirely possible that we look back and look at the totals for California, for Arizona, and it's like average or above average, right?
Sure, yep.
But that belies the fact that the early part or the first quarter or half of the season was dry, and that contributed to the sort of state of risk that we're experiencing now. So the nuance of it is important to track as we go through this.
I think it's true, but it's also to say though that we get into December and it's not too late to turn it around. That's the key point. You get to the end of January, it's tough.
Yeah, it becomes harder to make up for those deficits.
Yeah, you've missed your chance. You're probably a little bit more locked in. And that's where this La Niña event in place really starts to lean into January and looking at impacts.
The atmospheric rivers that we alluded to earlier, they, on average, there's something like 13 or 15 of them that hit California.
Yeah.
They happen in California in all months, but the peak of their months, I believe, is January.
Yeah,
and we haven't experienced
one. We haven't seen it either. It's been interesting too because the atmospheric rivers have been occurring, but they've been occurring over southern Alaska and British Columbia. And so there was a atmospheric river event earlier this month that appears to have set I think it was the snowfall record as far as the heaviest snowfall ever recorded in a period of time. So it was 10 inches per hour over, I think, an hour or two or several up in southern Alaska. And it was an atmospheric river event that literally was screaming straight north. So you think of that really amplified jet stream pattern we were just talking about in relation to the Santa Ana winds, is that as we were talking about the jet stream sort of moving straight north to south across the interior west, which was bringing in that cold air that funneled across California, further out in the Pacific, there was part of the jet stream that was screaming from south straight to north. And so that was dragging a long stretch of subtropical moisture all the way up into Alaska. So the atmospheric rivers are out there, and I think it is just a matter of the jet stream stretching itself out, changing position a bit, and maybe becoming less amplified and then striking California. I expect we will see one, probably at least one before the month's out, and then, like you said, maybe January shifts around for it.
We'll spend more time digging into ARs, as they're affectionately known, or the Pineapple Express, or the Hawaiian Fire Hose, or
Hawaiian Fire Hose. I haven't even heard of that one.
Yeah, I know, that was a cool
Is that true?
I might have made.
Did you hear that on
up.
Twitter? That sounds like something you saw on Twitter. I'm not so sure.
But one final point to the sort of disasters that these fires in California have contributed to. As I mentioned before, 2017 is going to go on the record books as the most billion-dollar disasters. We've had, I believe, 17 so far. Obviously, we talked a lot about the hurricanes, the back-to-back hurricanes beginning in late August, Harvey, Irma, and Maria, and now these two fires. And this is for all of United States. In that respect, we'll be happy to see 2017 go by the wayside.
Yeah, right. Maybe it'll be a bit calmer as we get into January, but
just a little bit more about recent conditions. I mean, the snowpack, obviously we've been dry for the most part in much of the West. The one part that has received some precipitation recently has been the Pacific Northwest. And so if you look at the snowpack basically across the West, it's coming in at much below average conditions, which unfortunately doesn't make those skiers happy. Looking at the maps, obviously, like the higher country in Arizona, as you alluded to earlier, and New Mexico is close to 0% of what they would otherwise have at this time of year. Colorado's, all of their sort of national resource conservation sites, snowtail sites are basically much below average. Utah's the same way. Oregon's the same way. Only when you get into the northern parts of Wyoming, the Tetons, and southern parts of Montana do you see some slightly above average rain. And that's probably, again, not rain, snow. And that's probably, again, the sort of position of the jet stream that's coming in more, but more overhead of those mountain ranges.
Just looking at precip, so the below average snowpack in northern Arizona and southern Utah and parts of Colorado aren't completely because it's been warm and just say it's rained on those locations. Some of those places haven't had any precip at all in the last 30 days. So, I mean, there's this hole in the Intermountain West of precip over the last month. And going from November into December, that area should have filled in by now. And so that really stands out to me as a really unusual part of what we're seeing this fall.
When you look at the western pattern of precipitation, particularly for the month of November, and it's dry for the most part in the west, and particularly in the southern parts of the west, and the Pacific Northwest has some above average rainfall, and that's kind of your quintessential La Niña expression. And we are now moving into one of the updates from last month is that La Niña is strengthening.
Yeah.
So we're now in a full-fledged La Niña, and there's talk about, we see this at the expression in the atmosphere. What do you make of this?
I don't know. I know.
Next.
Exactly. Is it La Niña? I think probably part of it. I don't think it's the only player in town, and I certainly don't think it's been a huge player. It's probably going to be an increasingly important part of the pattern as it's continued to strengthen. I think its reflection in the atmosphere is increased over time, but I don't think it was all that strong earlier in the middle part of the fall. And there's just so much other weird stuff going on. There's I follow Judah Cohen's stuff. He's a seasonal forecaster from a private company out east, and he's done a lot of work on Eurasian snow cover and its influence on disruption of the polar vortex, and he can do seasonal forecasts from that perspective. And there have been some sort of higher latitude Arctic sea ice interactions with higher latitude parts of the jet stream, Eurasian snow cover, larger scale hemispheric jet stream patterns that I think are part of this, and certainly probably working in concert with the tropics. The Madden-Julian oscillation has been really weak, but is increasing in strength. So there's some, and again, I think as you'd expect to see that as you get into northern hemisphere winter, stuff sort of shifts around, and you move from the fall things that drive the weather patterns into some of the more core things like El Nino. So I think La Niña is strengthening, Madden-Julian oscillation becoming more important. The Arctic seems like it becomes less important because it starts to grow the sea ice. So, there's that climate change aspect I think is really starting to now show up in the literature and the research and moving its way into operational forecasting. It's still real early on.
That's a substantial change up north.
It's a big deal. And I think at the American Geophysical Union last week, there's a lot of discussion about how the Arctic is just different now.
Yeah, and it's sort of changing a little bit of the common wisdom where
the tropics still drive the show, but it interacts with the higher latitudes, and I think that the higher latitudes interact with the tropics through these second and third order processes. There's that cool paper maybe we'll talk about upcoming podcast.
There's a new bench player come showing up for the game. Huh?
Right, I know.
To bring it back to ENSO, I mean, I was sort of...
Was this a way... You tricked me into talking about El Nino.
I did.
I said I'd never talk about this stuff again.
Well, I can get you excited when you sort of go into the Arctic and ENSO and all the players and
I don't understand
all the complexity.
I don't understand any of it. I just see a bunch of stuff that probably fits together. I don't know how it works.
But, okay, to bring this back to something a little bit more...
Useful?
Yeah,
focus on the
concrete
region? What does it mean? Yeah, that's a good idea.
I mean, I sort of brought up this topic by talking about the pattern in November, and I think it's important when we talk about these phenomena like ENSO that we don't get stuck on just like a short-term pattern, like a month pattern. Like, the expression is there, but let's see how the season plays out.
Exactly. I'm not ready to call it, based on 1 month. There's just so much
weather
going
happens,
on.
And weather can be persistent.
My bumper sticker says.
Does it really?
Weather happens.
You're
looking at me like, does he really have a bumper sticker that says that?
Weather happens. I like that. So,
what's your bet?
Yeah. So, are we to the point where we predict? I wish I had a magic 8-ball.
I have one, but I told you that all the 8-ball juice leaked out of it. It doesn't work anymore. All right, it's the only place I've ever lived where a magic 8-ball dried out. It's the saddest thing I ever saw. Okay, so I'm gonna base my prediction on the flaw in my logic from the monsoon. Oh, God.
So for the monsoon, my prediction was solely based on persistence.
Okay.
And this time, and it didn't work out.
Right.
So I'm going with anti-persistence. Anti-persistence. So I think it's actually going to turn out to be a good winter. Slow start. I'm not saying it's going to be record-setting, but I think we're going to, when we look back on its entirety and don't try to characterize it by its nuance, then I think it'll.
What are you saying?
I
want a number.
I think it's going to be slightly above average.
I want to know what it looks like.
It's going to be slightly above average. I think it's going to be 110% of average. How about that?
Oh my gosh!
Yeah.
Are you really?
Yeah.
Okay. 110% of average.
No, 105.
Oh.
Yeah, you're making me question this.
Okay, so I'm just looking at I'm going to plot here. So by March, it's about 3 inches. So you have to have about 3 inches over the next.
It just doesn't seem like a lot.
I watched my rain gauge fill up for 24 hours and it gave me 0.3 of an inch. I couldn't believe how long it rained, and that's all I got out of that. So it's got to run 10 times like that. I'm saying go for it.
Yeah, I know. Listen. This isn't based on anything.
I know
scientific,
it's not.
Right? It's based on the fact that I got misled during the monsoon. So I don't know. What do you think?
It's a really good question. I was hoping I didn't have to answer that.
Yeah.
After just giving you all that razzing. I think if we get 2 more inches in total, that's it.
I just completely disregarded La Niña.
I know you did. That's why I was impressed. I was impressed by that hubris.
I don't want to bet.
No, you're in, man. You're locked in. So what are the numbers again?
Well, I mean, if
3.5 inches for you, 2 inches for me.
Yeah. Okay. Yeah. I mean, La Niñas, for the record, they tend to statistically, there's a greater chance of conditions being drier than average than El Niños being wetter than average, right? Like the cluster, like there are very few.
We've said that before.
Yeah, there are very few La Niña years that actually produce
the forecast that you just made.
Yeah,
yeah. That's why I'm really impressed by it. Should I give you? Do we give you better odds?
So let's wrap this up. But let me tie it back to fire because I didn't ask a question that I really want to have an answer to. When did these Santa Ana winds sort of die down?
When do they die down?
Yeah,
typically in December. And I think that a paper we were talking about by Tony Westerling noted in there, this was in 2004 at least, was that there have been some reported instances of Santa Ana winds that will extend into February. But typically the whole jet stream pattern should start to sag south, right, as we get into Northern Hemisphere winter. So you're going to start to see the jet stream kind of coming into the California coast more directly. And so you don't have the dynamics anymore of that interior cold air building up in the Colorado Basin.
Now, what if
in the Great Basin?
What about during La Niña years where the jet stream is actually further north?
I don't know. It's a good question. I haven't seen any papers contingent.
But the La Niña years also tend to make the amplitude of the jet stream not quite as high, right? So.
Well, you get that split jet. I mean, you could have the ridging over the west, but I still, California. The jet then starts to come in across the Pacific Northwest, and so the dynamics for that Great Basin high tend to get washed out as you get further into the winter season. So, but hey,
all right,
this could be the year, right?
And let's end this with what's 2017 is very likely, I'd say at 99% sure, to go in the record books for the Tucson as the warmest year on record.
I think you're right.
March, June, and November were all the warmest on record for Tucson. So, and I believe for the U.S. in general, 2017 will be the warmest year on record. So we can usher out 2017 with that bit of good news.
Yeah, let's try not to do it again in.
Records. Yeah, I grew up thinking records were great, but when they're continually broken, like you're wondering if like something's wrong.
That's a good way of thinking about it. I think that's
like performance enhancing drugs or something.
I think you're onto something, Zach. I think you're onto something.
Mike, excellent to see you again.
Merry Christmas, Happy Holidays.
Your beard's looking good.
Think so. Combed it out. Yep.
It's getting long.
It is. It's getting long. That'll be. Maybe I have to do a bet that I'm not. No, I'm betting beverages, not shaving
mustaches.
It off. No, not doing soul patch. Not doing anything like that.
Okay.
Not doing this. Too much work to get this beard this way. Yeah, it'd take me years to do that.
All right, if we were doing that, I'd be more serious.
I know you would. Then you would have I don't want to.
Because there's some repercussions there.
Exactly. If you could get me to shave my beard off, I think you would have brought La Niña into your forecast a little more heavily. So what are the numbers again?
I think 3.5 inches for me, and what did you say? 2?
Yeah.
All right. Well, thanks everybody again. We'll come back sometime in late January and talk about the really great wet conditions that we've experienced in the last month. So
on our way to 3.5.
Happy holidays,
right.
And looking forward to 2018, Mike.
The road to 3.5.
Your number
inches.
what year is this? You're number 5, I think, doing this, right? Longest.
I think it's longer than that.
Longest lasting
podcast on Southwest Climate.
On Southwest
recorded
Climate
in Tucson ever.
We'll take it. Another record.
into the books.
All right. Cheers.
The Southwest Climate Podcast is a production of CLIMAS, which is part of NOAA's Regional Integrated Science and Assessment Program and is housed at the University of Arizona Institute of the Environment. Mike Crimmins is a principal investigator with CLIMAS, a professor of soil, water, and environmental science in the College of Agriculture and Life Sciences, and climate extension specialist with the University of Arizona Cooperative Extension. Zack Guido is a research scientist with the Institute of the Environment and UA program manager of the International Research and Applications Program. The podcast is edited and produced by Ben McMahon, research, outreach, and assessment specialist with CLIMAS.
I looked up quippy too.
Oh, that's good. Quippy's not a word, is it?
Well, quip is quippy.
Quippy, I'm not sure.
I mean, it produced some substantial. Excuse me as I say that.
Is that a new word too? Okay. This is your new year. Did you get one of those calendars with a new word on it every day?
Substantial.
To the end of the year, you got to use it up.